Hi all, we from Industrial Infra Coaching Centre, we started a YouTube channel. About our institute, I want to give small introduction. We started an Infra Coaching Centre. Infra in the sense infrastructure structure of the metallurgists, non-metallurgists who are there in the metallurgical field. So we will give the best coaching for metallurgical entrance exams or diploma, BTech or job field guys. So ESET coaching also we are giving. For the metallurgists to support you guys, we have been started a YouTube channel. If you want further more deeply knowledge, kindly contact us in our institute or through our phones, or you can ping us on the same WhatsApp numbers or there which we have given in this video. And below of this video description, we are giving our deep introduction as well as our contact details, as well as we are also running in a WhatsApp group with the same description also I am giving here. So let us start our session of today's. Yeah. In this session, we are discussing about the tensile testing. This discussion of tensile test will be done as per the national or international standards. In this session, we will discuss the sample specific requirements and properties calculations as per the standards. Kindly subscribe our channel to get latest updates on our further videos, and it will be an encourage for us. If you subscribe, we will think that yes, a lot of people are interested, so that from there we can understand it to do more videos. We can think deeply. It will be really encouraged for us. Kindly support us. The tensile testing generally will be carried out as per the national or international standards. If we consider the national standard of Indian standard, the Indian standard designation is IS 1608, and if we consider the ASTM, the ASTM designation is ASTM E8M, and sample specifications or samples terminology is been given in this shown picture. The gauge length and reduced section, which means parallel length, and distance between the shoulders. Shoulder means the part which we are using for the gripping of the sample, that is also called as grip section, and overall length of the sample. These are the requirements, standard requirements. This parallel diameter, whatever it is there we are discussing, parallel section, that parallel section width or diameter, if we consider the round sample, the diameter, and if we consider the flat sample, the width is being fixed as per the national standards throughout the world. Tensile testing will be carried out to find out or to determine the properties of tensile strength or ultimate strength or peak strength, yield stress or yield strength, percentage of elongation, and percentage of reduction area. If we consider the formulas of each property, tensile strength formula is max load or peak load, whichever it is taken during the test, divided by with original cross sectional area. The original cross sectional area calculation is very simple and has been we already learned in the previous primary school or secondary schools. Here I am mentioning the original cross sectional area formula for round samples as well as flat samples. If we consider the round sample, the cross sectional area formula is pi r square, and if we consider the flat sample, the cross sectional area formula is width into thick. So moving forward, for calculation of yield strength, the formula is yield point or yield load divided by original cross sectional area. Yield point is nothing but the point where plastic deformation will takes place, or ending point of elasticity limit. So that point or that load divided by with original cross sectional area is called as yield strength. Coming to the point of percentage of elongation. Percentage of elongation is nothing but change in the length divided by with original length or original gauge length. Change in the length divided by with original length multiplied with 100 is the percentage of elongation formula. If we want to get now the change in length, the difference between initial gauge length and final gauge For calculating the percentage of elongation, gauge length determination is most important. Gauge length determination in the sense the gauge length is being marked as per very initially I have mentioned gauge length in the figure of sample. The gauge length is marked. From where we will get the gauge length? For round samples, as per the IS standard, IS 1608 standard, we need to find out the gauge length as per the formula. The formula is L equals to, gauge length equals to constant value multiply with square root of original cross sectional area. The constant value is been given as 5.65 and A0 means original cross sectional area, which we need to calculate it as earlier we discussed. And then so from there we can find out the gauge length. Coming to the last point and very much of interesting point is reduction in area. The cross sectional area, how much it has been reduced initially compared with after fracture. So for this to determine, the formula is change in cross sectional area divided by original cross sectional area multiply 100. The change in cross sectional area is nothing but it is similar to the percentage of elongation. There we calculate it as change in the gauge length. Here we need to calculate it as change in cross sectional area, means final cross sectional area and initial cross sectional area difference. Initial cross sectional area minus final cross sectional area is known as change in cross sectional area divided by original cross sectional area multiply 100 is known as reduction in cross sectional area. As per ASTM, these are the dimensions which sample should be maintained. As per these dimensions, sample needs to be prepared. So after preparation of sample, as per these dimensions, the test will be conducted as per ASTM E8M. Here, as per IS 1608, all the dimensions of the sample has been listed out. For the flat sample, first tabular is the dimensions parameters which needs to be maintained. The original gauge length should not be calculated for the flat samples as per IS. It has been fixed as per the Indian standard. And below figure is containing the dimensions of the round sample. Here, the diameter wise 5 mm, 10 mm, 20 mm. The diameter wise, the original cross sectional area has been listed out, but it should be calculated based on the original dimensions. And original gauge length also needs to be calculated as per the original diameter. And reduced section parallel length also needs to be maintained as per the standards only. Here, some of the graphs are being listed out here for the different alloy steels. For first one is low alloy steel, second one is brittle material, and third one is stainless steel. Whereas first one, if we consider the tensile stress and yield stress, almost both are to the same point. Whereas brittle material, if we see, it will not be yield stress and tensile strength both will be same, almost same, 99% situations. There will not be elongation in for the brittle material. And third one is stainless steels. In the stainless steels, elongation will occurs very hugely, and tensile strength and yield stress